Okay. So for this presentation, I will just present a very general about the application on the drinking water process and some solution from Hach, like some controller and some sensor, some analyzer for this application. Okay, I will just go through overview about the drinking water treatment process. So for drinking water treatment process, there will be different process treatment process, but the general one will be particle removal. So normally we use the sedimentation tank. There will be concentrate coagulation, flocculation, and sedimentation. That is the whole process to remove particle. After the sedimentation tank, there will be filtration, like filter. So normally we will have sand filter to fill the water. After the particle removal process, we will go through the disinfection process. Here, normally for drinking water, we use chlorine, but there's also other options like ozone or chlorine dioxide. Chlorine dioxide will be like more expensive than chlorine. So most of the drinking water plant we use chlorine. There will be also some additional additional process like organic removal. Normally, we can use activated carbon to remove organic compounds. In case we have high organic contents in raw water, we can have also that step. Another step may be additional step may be pH or corrosion correction. Use either different method. This is the whole process for drinking water treatment. Normally, we only have particle removal and disinfection. So this is two mostly used in drinking water treatment process. Okay. So in an drinking water treatment plant, we will have like mix like a pump to pump water from either river or some well. So in case we use groundwater source, we will have we will need to pump water from some deep well and then go to the process. In case we use groundwater, normally the treatment process will be only disinfection because groundwater is already very clean. We do not need to do any particle removal step. We will go directly to disinfection and then flow and then transfer the water to the distribution system. In case we use river water, we'll need to have particle removal process that will be mixer, flocculator, and clarifier to use to go with coagulation, flocculation, and sedimentation process. Over here, we will use either PAC or some sort of aluminum or iron to for the coagulation process. After that, we can also use some polymer to speed up the sedimentation process. After the sedimentation tank, we will go through filter. Over here, normally for drinking water process, we can use sand filter. This is the most used process for filtration. And we have also different options like the upflow, filter. I also see that filter in some drinking water plant. After the filtration, we go through disinfection. Normally, we use chlorine. So after the disinfection, the water will be transferred to distribution system. Okay, that is the very general process of the drinking water treatment. Okay, if we use groundwater, there will be some parameter that we need to monitor. So normally for groundwater, we only pump the water to the system and then do the disinfecting. So we because groundwater is very clean, that we do not need to go through the particle removal step. We go directly to disinfection. So we only need to monitor like pH, conductivity to see if there is a lot of hardness, a lot of matter in the water or not. And then we also need to check the turbidity to see if the groundwater is really clean enough or not, or we need to do some additional treatment. If it's very clean enough, it means that the turbidity is less than like 2 NTU. 2 NTU is the standard in Vietnam. I'm not sure in Philippines what is the standard for drinking water, but in Vietnam we use the limit will be 2 NTU. It is clean. For this step, we use the TU5, TU40, 5300 for online, and TU 5200 for labs to monitor the turbidity. So these two use the same technology, the 90 multiply and to 360 degree detection technology. This is a patented technology from Hach. So we monitor the turbidity of the water. If it's very clean, we'll go to disinfection. So normally we use chlorine to monitor to disinfect the water. From here, if we use chlorine, we will use the Cl 70s to monitor the residual chlorine. So that is what we monitor for groundwater. Okay, sometimes we also measure pH at the outlet. So pH, stability, and chlorine. This will be three essential parameters for finished water monitoring. For all of the drinking water plants, we need to monitor these three parameters. Okay, if we use surface water, we need to monitor. So this is the very general step of the drinking water process. At the intake, we need to monitor either organic and particulated matter. For example, we monitor turbidity or TSAO, and we also monitor organic because surface water is the source water that very easy to be contaminated by human. So sometimes surface water can have very high organic content. So we need to monitor. For some river, we also need to monitor ammonium because that is also a parameter that can be very high in water source, in regular water source. Okay, so some parameter that we need to monitor at the inlet of the drinking water plants. There shall be manganese iron. Manganese iron can be also very high for river water and also groundwater. And sometimes we also need to monitor alkalinities, ammonia, pH, oil in water, and ATPs. ATPs is the indicator for virus or bacteria. So for bacteria, we monitor ATP for online application. So for oil in water, we have the FP 360 SC. For iron, manganese, alkalinities, or ATP, we will have the easy series analyzer. For pH, we have the pHD, and for TOC, we have the B3500 DW. DW is meant for drinking water. We also in Vietnam, we also already install some TOC analyzer for some drinking water treatment plant. We like have 3 or 4 plants we install the TOC analyzer for monitor the organic contents for the inlet of the plant. Ammonium, we can have the AMTAX or the ACE sensor. For turbidity, for the inlet, we can use the Solitax, or we can also have the Ultratop. We have different choice for turbidity at the inlet of the drinking water treatment plant. After the intake, there will be a screening. So normally we can have some screening like this or like this. The plants can choose different option for screening to remove the garbage for the river water. Turbidity measurement. For turbidity measurement, we use all of these turbidity sensor or analyzer. We use the same method, the same principle. Is a nephelometric method. So we measure the turbidity with the 90-degree angle to detect the turbidity. For raw water, we have different options. Normally, we can use immersion solution with Solitax. Solitax, we can have option with turbidity or both turbidity and TSAO. So for raw water, we can use this one, or either we can use the bypass solution. For bypass solution, we can use surface scatter or Untitled. Normally with raw water, I will not recommend TU5 because TU5 normally we can use for we use this for filter water. So for raw water, we can use either Solitax, surface scatter, or Untitled for turbidity monitoring. The different only on the installation solution, either immersion or bypass, and also they will be also different in the range. So for Solitax, the range will be 0 to 4,000 NTUs. Surface scatter will be from 0 to 10,000, and Untitled will be 0 to 1,000. So with different range, we just choose the right solution for the right range of the raw water. Okay, just some information. For this one, I will not go very detailed. For surface scatter, the option will be there'll be a light source over here and a detector at a 90-degree angle to measure turbidity, and all of the optical part component will not touch the water. The water will come to here and go go down to the drain. So the optical will not touch the water. The range shall be from 0 to 10,000. This one we install also a lot in Vietnam because it's very robust. It's a little big. You can see this one is the controller and the sensor will be that big, but it's very robust. The problem is that the accuracy is not very good because the optical part is not touched the water, so there will be also some problem for the accuracy. But in some case, if the raw water turbidity is very high, like more than 4,000, we can use this one. Another option shall be ultra-top. Ultra-top, this one also robust, but the range is lower, only from 0 to 1,000. This is also very robust. That can also be used for seawater. So very robust. We can also use this one for river water where the turbidity is lower than 1,000. We can use this one. In case we want to measure turbidity for seawater, we can also use this one. So bypass, the water will come through over here and go out. Inside there will be an optical system to monitor turbidity. Okay, another option shall be the Solitax. Solitax can measure both TSAO and turbidity. So for TSAO, there will be two options of the range from 0 to 50 gram per liter, or from 0 to 500 gram per liter. Or we can also measure turbidity. We cannot measure both at the same time. We need to switch either TSAO or turbidity. So if you want to measure both, you will need to have two sensors. But you can switch from one to each other, to another, from one to another. Mountain will be immersion. So when you immerse directly the sensor into the water to measure turbidity. Normally, this one can be used for raw water. The range is from 0 to 4,000 MTU. They're also robust. This one can also be used to measure sludge density for some sludge treatment. We switch to TSAO and we can measure sludge up to 50 gram per liter. Next, we will to oxidation. So we call it pre-oxidation. Normally, we can pre-oxidize the water in case we have a lot of algae, or we want to disinfect the water. If we have a lot of bacteria for the water, raw water, we can have also the pre-oxidation process. And we also use for pre-oxidation process, what is the use? The use may be to remove taste, odor, to improve filter performance, or to reduce the formation of DBP. Because when we have pre-oxidation, we can treat a little of the organic compound, the raw water organic compound. So we can reduce the formation of DBP, disinfection byproduct, and to provide coagulation head also. That's the use of pre-oxidation. And we can use either chlorine, ozone, chloramine, or the other oxidant. Normally, I do not see very often pre-oxidation in the drinking water plant, but some plant they are also this process. Okay, we can use either chlorine or ozone. If you use chlorine, you will need to monitor the residual chlorine. So you can use either the Cl 70s or the 91AX chlorine sensor. This one use sensor and this one use analyzer with reagent. Okay, that is for oxidation, pre-oxidation. Now we go through coagulation and flocculation and sedimentation. This step is the mandatory process. We always see this one in river water, drinking water treatment process. So the use of this step is to remove a particle. So we need to dose chemical. We use a PAC or the zone of aluminum or iron for the to use as coagulant. Why we need to use that? Because in the water, you can see sometimes you can see the color, because there is a lot of very small particle that cannot be cannot settle down by themselves. So we need to treat it by using chemical, by using PAC or polymer to improve the sedimentation process. Because if we do not use chemical, the very small particle cannot be settled down. Just talk a little more about the theory. For the large particle, it can settle down, but if inside we have a lot of very small particle, that small particle will have a negative charge, and because all of them very small particle, they are negative charge. Negative charge will push each other. So the small particle will push each other, and they will not settle down. That's why we need to dose the chemical, the salt of iron and aluminum, which is positive charge, to eliminate the negative charge, and that and that's how the small particle can settle down, because we already eliminate the negative charge to have the neutral charge that the small particle can settle down. That's the theoretical theory of the correlation and flocculation process. From here, when we measure the correlation and flocculation process, because we the theories is that we with those the chemical, the salt of iron and aluminum, which have positive charge to neutralize the negative charge of the very small particle. That's why over here we can use a swimming current to monitor the process and to optimize the process. The principle of this one is to monitor the current. So the purpose of this process is that we want to neutralize all of the negative charge. So the optimized condition is that we have zero charge at this point. So if we have zero charge, it means that we already dose enough positive charge with the coagulant to neutralize all of the negative charge. So if we have zero charge over here, this means that we are at the optimized state. In case that we have negative charge, it means that the dosing of the PACs is not enough. In this case, we have positive charge over here. It means that we already overdose coagulant with overdose the iron or the aluminum iron. So that's how we monitor the current over here to optimize the chemical dose. So for that, we use the AF 7000 over here. In Vietnam, we also install already like 2 or 3 drinking water plant with this device, the AF 7000. We have also a lot of installed in Philippines and in in Malaysia. We also install a lot of this AF 7000 for the drinking water plant. The other parameters is what we already present. We have at the inlet, we have UVAX, we have the biodetector for organic monitoring. For stability, we can have either SS surface color 7 or solid tax. For pH, we have PhD. So all of those, the UVAX, SS7, solid tax or PhD, we will need a controller. For biotector, we do not need any controller. This one is there will be already controller inside. After the coagulation, we will need to monitor pH or current. For current, we use the AF 7000. At the outlet of a sedimentation tank, we need to monitor turbidity. Over here, I still recommend to use either solid tax or solid tax would be best over here. But in case we have very clear water at the outlet of the sedimentation tank, we can still use the TU5, TU 5300 for turbidity measurement. After the filtration, again we need to measure turbidity to see the finished water is already good quality with lower 2 NTUs of turbidity. That is the standard for drinking water in Vietnam. For Philippines, that may be different. Okay, this is what we have for the whole drinking water process. At the outlet, we also may need to measure also the organic compound to see the organic removal performance. So we measure organic compound at the inlet and the outlet of the process to see the organic removal performance. Okay. So this one is for swimming to measure the charge of the water at the outlet of mixing tank after those PAC, just to optimize the chemical dosing. So with this one, we can reduce the coagulant. Normally, we use PAC chemical cost average of 20 to 30%. This is quite a lot of money for to save. Next, we'll go through filtration. So after the filtration, normally for filtration we use a sand filter, but we have now we have also another option is the upflow filter. Also, I also see that in Vietnam. Maybe in Philippines we also use already that upflow filter. So after the filtration, we will need to measure turbidity. For after the filtration for turbidity, normally we can measure with the TU5, TU 5300 to measure low turbidity. For each after each filter, we can install the turbidity meter to measure the filtration performance. After that, at the outlet of the whole system, we can also measure the common pi to see the common turbidity of the plant. So we can measure after each filter and after the common pi of the plant. Just to talk about the technology of the TU files over here. So so for other turbidity meter from other branch, we use only one detector at the 90-degree angle. But with TU files design, we can capture 90-degree scatter, but multiply with 360 degree over here. So we can have a round mirror that can capture all of the scatter line at 90-degree degree. So with this technology, this design, we can have more scatter line to be captured. So the accuracy will be higher. This one, the TU's 5300 SC turbidity method is used for filter water. So at the outlet of the drinking water process, the range will be from 0 to 1000 NTUs. We also have option with automatic cleaning module over here, so we can install and automatic cleaning to support the maintenance tasks. So with this one, we will have lower maintenance task because we have also write this one for clean the vial inside. This one will be connected to controller, so we can use either SC 4500 or SC 1000. Okay, question. Okay, next we also have application for filter backwash. If we use sand filter, so after some time, some operation time, we will need to backwash. At the backwash, purpose is to wash the filter, and we can use a turbidity measure to measure and to monitor the backwash operation. So normally for backwash in a drinking water plant, we can use air and water, combine of air and water to wash the filter. So after the backwash, we can use normally for all of the drinking water process, we will use timer. We will timer to control the backwash time. And if we use only timer, we may waste a lot of water because we do not know. We will have a fixed time for backwash, but to save water, we can use a turbidity meter at the outlet of the filter to control the backwash time. So in case we have low turbidity at the outlet of the backwash operation, we can already stop the backwash operation and save some water. That is the purpose of the backwash operation monitoring. And for that, we can use a turbidity meter, and over here we use this Solitex. So we can install a Solitex at the outlets of the channel to measure, to continuously measure turbidity. So when we have low turbidity at backwash wash water, this means that the water is already clean, the filter is already clean, so we can stop the backwash operation to save some water. If we do not have that, we use timer. The water pump will run until the end of the backwash time. And sometimes this is not necessary because water at that moment is already clean, but we still pump the water, so we will lose some water. So instead of that, we can use a Solitex, and we can install at the backwash channel to monitor and to stop the backwash pump at the right time to save water. That is another application for drinking water treatment. Okay. Okay. Next, after the filtration, there will be the last application, that the last process will be disinfection. For disinfection, normally we use chlorine to disinfect the water. So if we use chlorine, we need to measure, we need to monitor residual chlorine. So for measure residual chlorine from Hach, we have two different options. The first one shall be using a sensor. So for sensor, we also have two different options. The first one will be the 9184 SC chlorine analyzer. This one will come with a pH sensor. So we have pH sensor and chlorine sensor. So this one is an option for sensor chlorine monitoring. We also have another option which is the CF10 SC. For this slide, I do not have that product, but you can use also this one. This one use a sensor to monitor chlorine. The strong point of this one is that we do not use reagent. So this one is reagentless solution. So we do not use reagents, but we need to maintenance more frequently than the CL70s. We need to clean the sensor and also change the membrane and the electrolyte inside the sensor more frequently. Normally, the interval will be 3 months, or after 3 months, or after 6 months. We need to change the sensor membrane and fill up the electrolyte. The problem of this solution is that in case in the water have high solid or high iron or high manganese, the membrane can be blocked with iron, manganese, or high solid. So we need to clean and change the membrane very frequently. The only strong point is that we do not need to use reagents for the solution. Another solution for chlorine monitoring is that we can use colorimetric chlorine analyzer, the CL70SC. So good point for the strong point for this solutions is that we do not need to calibration. This one do not require calibration. For the maintenance, we only need to change the reagent monthly and change the pipe over here yearly. So every year we need to change this one, and every month we need to fill up the reagent, change the new one, the reagent, and every kit of reagent can last 30 days of measurement. This solution is not affected by change of chlorine concentration, change of pH, temperature, flow, or pressure. If we use a sensor to monitor chlorine, that solution will be affected by chlorine change of chlorine concentration, change of pH, change of temperature, flow, and pressure. So every solution have a strong point and weak point. Normally, I recommend to use this CL70SC because we only need to change. We only need to fill up the controller, and it will operate very good. We do not need to do a lot of maintenance tasks with this product. Of course, the CL70SC or the 9184SC analyzer, chlorine analyzer, we still need to have a controller. Normally, we can use either SC4500 or SC1000. Okay, this one is only the information we can find in the data sheet. For pH, we have the pHD sensor. Of course, this one also will be connected to the SC4500. The good point, the strong part of this one is that we can change the storm rate and we can fill up with electrolyte, and with that, the sensor can last longer than the other sensor. For the other sensor from the other branch, after some time, like 6 months or 1 year, we will need to replace the whole sensor. But from Hach, the pH-D sensor, we can change. We can only replace the sulfate and top up, fill up with electrolyte, and then the sensor can last longer, like more than 2 years or 3 years or even more. So we can use this one for even either wastewater or drinking water. For pH, normally we can measure at the inlet for raw water and for finished water. Okay. Next, if we use even groundwater or river water, we may need to measure nitrate. I'm not sure in other country like in Philippines or in Malaysia, what is the limit of nitrate content? But in Vietnam, the limit will be only 2 ppm. So maximum 2 ppm nitrate at the inlet of the drinking water. So we need to also measure the nitrate content in either groundwater or drinking water. Especially if we use river water, this can be blending salts with raw water and wastewater. So sometimes the nitrate content can be very high. So we need to measure nitrate in raw water. For nitrate, we have the NT3. NT3 is the new nitrate sensor, which is to replace the legacy one, and the Nitrate from Hach. Nitrate is already obsolete and replaced by NT3. For NT3, we have two different options. The NT3100, which can measure only nitrate. We also have model the NT3200, which can measure both nitrate and nitrate. And normally this one is used for wastewater. For drinking water, we can use only NT91. 3100, it will be okay already. And we have 3 different options based on the range. So for the children range, we choose the right pack length, 1 millimeter, 2 millimeter, or 5 millimeter. Normally for drinking water, the 5 millimeter pack length is suitable. So the range will be from 0 to 25 milligram per liter nitrate. This one can be installed either immersion or bypass. If bypass, we use this bypass mounting panel. But of course, we can also install immersion as parameter. For drinking water, we may also need to measure organic compound, iron and manganese, because I said that for river water, even river water or drinking or groundwater, the iron and manganese content can be also very high. And especially for river water, the organic compound can be very high. If we have high organic contents in raw water, after the disinfection process, we can produce a lot of DBP, the disinfection byproduct, and it's harmful to human health. So we need to very strictly monitor organic iron or manganese in raw water. For TOC, for organic monitoring, Hach offer the biodetector TOC analyzer. Some information about this product. We have very low maintenance for biodetector. We only need to do the service with a 6-month interval. So we need to replace some part and do the calibration every 6 months. we have high reliability for this product. So uptime up to 99% MSEC certifies. Not affected by fat, oil, grease, salt, or particulate. Do not need to have any filtration for sample. A very simple application operation. This is some information about biotector TOC analyzer. Biotector analyzer to measure TOC from Hach have patented technology, two-stage advanced oxidation TSAO. Only Hach product, only biotector can have this technology. On the market, we can have different oxidation technology like thermal or UV passion fab. But from Hach, we use TSAO technology, which have powerful oxidation capabilities and can handle the salt content up to 30%. Can handle also some oil, fat, grease, particulate. No need to have any filtration. We have also have self-cleaning reactor, self-cleaning sample line, low maintenance and high reliability with more than 99% uptime. That's the information for TOC. For TOC measurement, for raw water, we can use either B3500E over here. Is means the effluent, but we can also use this one for raw water because raw water may have a lot of TLS and particulate. So we can use this the B3500 effluent because this one have automatic cleaning of the pipe and also the reactor. So it's more suitable for raw water, which may have a high TLS or turbidity content. The range for TOC would be from 0 to 250 ppm. So we can use this one for raw water. The cycle time is 7.5 minutes. So in Vietnam, we already installed like 3 or 4 units of this one for drinking water plant. Because in Vietnam, in 2019, in a very big drinking water plant, we have an issue of oil contamination in raw water, and after that problem, they install a biotector to continuously monitor organic content in raw water to avoid that problem. Also, after that issue, there was also like 2 or 3 plants also install this one to continuously monitor organic compound to avoid any contamination, organic contamination in raw water. For the outlet of the plant, we can also use the B3500 DW analyzer to monitor COC to make sure that the water is clean and the organic contents is within limit. So this one have the range from 0 to 25. This model had option of 2 streams, so we can use one biotector B3500 DW for both inlet and outlet of the plant. We want to measure organic compound COC. Okay. For iron and manganese, we use the Easy series, and we use the Easy 1000 and Easy 2000. And this one is colorimetric analyzer to measure iron and manganese. Use the same principle as laboratory process. So we use colorimetric method to monitor iron and manganese in raw water and finished water. Easy 2000 is the one is same as Easy 1000, but we have a digestion system to be able to measure total iron or total manganese. So to measure total iron and manganese, we need to go through digestion process before monitoring, before measurement. So if we want to measure total iron and manganese, we use the Easy 2000 series. If we want to only measure the zone iron or the zone manganese, we use the Easy 1000. Okay, the range for that, the standard range will be from 0 to 1 ppm for manganese and also iron. We have also different range, higher, like up to 20 ppm. But for raw water, the limit in Vietnam also will be lower than 1 ppm. So the standard range 0 to 1 ppm for iron and manganese is good for drinking water application. Same for iron, we also have the standard range is from 0 to 1 ppm. This one can measure the Easy 1000 to measure this zone iron, and Easy 2000 to measure the total iron. Okay, that's all of the product and solution for drinking water.